let's try talking about section 10.4 for a minute. Okay, so 10.4 is roughly solving equations involving root things. Okay? Equations involving rooty things. Okay, so first things first, we should probably talk about where this business comes from. Cool? Alright, so let's see. We've seen the Pythagorean Theorem in this class, right? Okay, so what's the Pythagorean Theorem say? Okay, it says if something, then something. You guys all seem to know the then, right? What's the then? A squared plus b squared is c squared, right?
Yeah.
What's the if that goes with this? In other words, when is this thing useful? Okay, triangle that's right with C is the important thing. Where does C have to go? C has to be the long side, right? The A and the B don't really matter. See that? And get a pretty similar picture by flipping this over, right? The things that matter are that there's a right angle and that the long side's labeled C. The two short sides can be labeled A or B, it doesn't matter which. Cool? All right, so if this, then that. Okay, good. You guys want to know a use of this thing? Yeah, besides triangles. Well, it's kind of triangles anyway. So there's this thing called the distance formula. Okay? The distance formula takes a pair of points in the plane and tells you how far apart they are. Takes a pair of points in the plane, tells you how far apart they are. Go with that? Yeah.
Does it work with the 45, 45, 90 triangles?
Yes.
Yeah.
Yep. Right? They satisfy this. They have a right angle, and then I can label the sides this way. So as long as I make sure C is the hypotenuse, it'll work with any kind of whatever 90 triangle. Cool? All right, so I want to work with the distance formula, which is this thing that goes, okay, here's a plane, right? So this is my usual Cartesian XY plane. If I have 2 points in here, any old points, there's say x1, y1, and x2, y2.
And do you think it's crucial for us to write this down?
Yeah.
Okay, so that's the formula.
Yeah, I'm going to write down the formula here.
Okay, I'm sorry.
No worries. Okay, so the formula is going to work this way. I want to know how far these 2 points are apart, right? Yeah. So this is going to be an if-then statement like the Pythagorean Theorem. So if I have x1 and y1 in the plane, sorry, x1, y1, and x2, y2 in the plane, these 2 points, then I can say something like x1, y1, and x2, y2 are blank apart. Right? Or the distance between x1, y1, and x2, y2 is. Does that make sense? So those are equivalent statements. I don't care which one you use. Cool? All right, so I want to know how to fill in the blank, right? Okay, so I want to look at this picture and say, how far apart are these things? Well, let me think. There's a distance here and a distance here. see those? And then there's this other thing, which is this distance. So there's this slope, right? You guys see the slope of the line here?
That would be the C, correct?
That's not the C. The C here I'm looking for is a distance. So what's the C in my picture? The blue is pretty clearly the C off this triangle, right? Okay. What's the blue also? Which one's the, yeah, so I'm looking for how far apart these 2 points are, right? So which represents how far apart these 2 points are? Oh yeah, the blue one does. You guys see that? So if the blue ones, both how far apart they are and a C like in the Pythagorean theorem, then I should probably try to solve for blue, right? Okay, so to be ultra confusing, I'm going to label the blue D for distance, right? It's going to play the role of C in the Pythagorean theorem, right? So when I look at D, I'm really going to think C. Yeah, so D and C are going to play the same parts. Okay? Now let me think here. There should be an A and a B here, right?
No, those ones. It doesn't matter which side.
Okay, so let me label a side A and B, and then maybe we'll figure it out, right? What else do I need to know about this? So what were the important things in the Pythagorean theorem? That I had C on the long side, and
A and B didn't really matter, right?
the A and B didn't really matter. They just need to be in there, and I need a right angle. How do I know the angle in this corner is right? Yeah, because these are really, this one's parallel to the y-axis, this one's parallel to the x-axis, and those have a perpendicular intersection. That's a little subtle. Okay. So, let's see. I know that, what does the Pythagorean theorem tell me about my picture?
A squared, B squared is going to be your distance.
Okay, so a squared plus b squared is what? D. Oh, that's a bummer, right? You guys see that?
Yeah.
It's d squared.
So then we just undo it.
Okay, so how do I undo squaring?
We multiply it out. Divide it by
Square root, right? I want d by itself. So I should square root both sides here. But that's still a bummer, right? I get d is plus, wait, what did I just about say? Oh yeah, there's a plus or minus, right?
Distance cannot be negative.
Okay, so I put the plus or minus in, and then I think, but distance can't be negative. So I don't really need that. You guys see that? So I'm thinking here, plus minus not needed. Distance is bigger than 0. I guess I want bigger than or equal to 0, right? They might be the same point.
Is it always the distance formula?
Yeah, this is always the distance formula. So I need to figure out what A and B mean, though. Because right now, if somebody gave me a pair of points, I don't know how I would figure out how long A and B are. You guys see that? So let me think. A is in the which variable, the x or the y? You guys see that? So I'm going to look at A, and I'm going to think to myself, this is x direction. I'm going to look at B, and I'm going to think to myself,
Y.
that's y, right? You guys see that? Okay, so what I'd really like to write here is something like, okay, D is
Square root.
square root You guys see that? Probably not. Okay, so I want to know how big A is, right? A is in the x direction. So if I think about, okay, this point, right, x1, y1, has a x1 in this direction and a y1 in that direction. You guys want this picture blown up? Okay. So I've got a y1 height there and an x1 in the x direction, right? The other point is a, what's this? Yeah, that's the x2, right? And the, oh, there's a y2 here, right? Keep in mind that's not the label for A, right? Okay, so how long is A? Well, it's the distance from x2 to x1, right? So that's the bigger one minus the smaller one? You see that? Really, I just want to know how long this is, right? Yeah, I just subtract, right? Yeah, I don't know which one's bigger, but I'm going to square it anyway. You guys see that? So if I did the wrong one, it doesn't really matter, because -1 squared is 1, right? Okay, so I got x1 minus x2 here. What do I get in the other one? y1 minus y2. You see this? Okay, so x1, y1, and x2, y2 are the square root of x1 minus x2 squared plus y1 minus y2 squared apart. So this is the distance formula. Cool? So you can put either this whole thing in your head, which I would sort of recommend, or if you want to remember this like you remember the Pythagorean Theorem, you can just put this piece in your head. Cool?
Could you just show again where the x1 and x2 are?
Where these guys came from?
Yeah.
Yeah. So this point has an x coordinate of x1, right? This point has an x coordinate of x2. Then I want to know how far apart they are in the x direction. So I just take the, well, that's really the same thing as asking how far apart are these guys, right? And I take the right one minus the left one to figure that out.
What are you squaring?
I'm squaring it because I had to do the Pythagorean Theorem to get D. You guys cool with that? If you look at other books, you'll sometimes see this. So, or D is the square root of x2 minus x1 squared plus y2 minus y1 squared. Is this different?
I guess not.
Notationally it's different, right? But does it give the same result?
Not necessarily.
Definitely necessarily gives the same result.
You're subtracting smaller ones, the bigger ones and small.
Yeah, does it matter? Seems like it should, right?
Yeah.
Okay, let me ask this question again.
If I have a -15 and I'm subtracting the -3, that's not the same as a +16 subtracting.
No, it's not. But you didn't change the order you subtracted in, you changed the sign on one of them.
Okay.
Here, all I'm doing is swapping the order, right? You guys see that? Remember that thing we learned about factor out of -1? That swaps the order of subtraction? I'm squaring. So that factor of -1 doesn't matter. Another way to think about this would be the distance formula should give me the distance between two things, right? If I ask for the distance between point A and point B, that ought to be the same as the distance from point B to point A, right?
Yeah.
You guys see that? That's really this factor and -1 out thing. Okay, see that? So either option, they're both fine. I think this is the more common one. Yeah.
So that's our formula.
Yeah, so this is the distance formula.
So you would put the point that that's on for x, you would put, like, say it's on 9.
Yeah, so let's do an example. How about that?
With real numbers?
Yeah, with numbers. So, for example, how far is 2, 1 from 2, -3? Okay, so I would hope you say, all right, I'm going to pick one of these points to be x1, y1, and the other one to be x2, y2. Right? So I'm going to think, okay, this here is
X2, Y2.
sure. Beautiful thing about this, it doesn't matter at all. As long as they go together, you're good. Right? Here, this guy is what? X1, Y1. Okay. All right, now what? Cram them in the thing, right? Okay, so D equals square root, stuff squared, right?
2 minus 2.
Okay, either way, right? X2 minus X1 or X1 minus X2, doesn't matter. So let's do 2 minus 2. Okay, that piece is 0, right? And then this piece is -3 minus 1. Okay, so I get the square root of 0 squared plus -4 squared is 16. Keep in mind, I may as well be squaring 4 there, right? That's doing the subtraction the other way. Okay, so I get the square root of 16, which is 4. Okay, now I should check with my intuition, right? So let me graph these quick. You guys don't have to do this. I just want to check, right? First time using the distance formula, I should probably think about whether or not it worked. Okay, so let me see. 2, 1 is where?
On the right side.
Up here? How do I get to it?
Over 2 and 1.
Over 2, up 1, so there. The other guy is over 2, down 3. Oh. You guys see what happened? Yeah, there's not really a triangle here, right? There's not really a triangle here, right? It's 4 spaces, right? It's, okay, 1 space, 2, 3, 4 spaces up. Cool, it works, right? At least for vertical ones. You guys good with this? What's that?
Kind of like slope.
It feels a little bit like slope. It really, I hope it looks a lot like the Pythagorean Theorem. It really is. There isn't really anything else here. This is a very cool thing because this gives us an immediate way to get the equation of a circle. We could talk about it later if you want. Cool? All right, so let's solve a couple examples. How about? So this is where we would get things like radicals in equations that we might care about, right? We might say, okay, find a point that's 7 units from here with x coordinate, blah, blah, blah. Does that make sense? You guys want to try one of those? Oh, I'm sorry, I erased my distance formula. Oh, we'll have to remember it. Okay, so here's another example. Okay, so here's a word problem, right? Kind of, right? Find a point, 0, comma, question mark, right? That's 3 units from 2, 1.
So can we just put 3 in where the 0, the question mark is?
No.
No?
Why not? So it's 3 units from this point, right? Okay, so let me think.
So y is less than?
So here's x and y, right? Okay, this point is over 2 up 1, right? Okay, now points that look like this are where?
We don't know yet.
On the X.
On 0,
Yeah, there's 0 in the x, right? So points that look like that live where?
on the y.
They live on the y-axis, right? So these are my 0, comma, question mark, right? All of those guys. Now I want to find something that's 3 units from here.
What does that 3 into 1?
So what's 3 units from here look like?
Is it up or over?
Yeah, so it's not going to be up or over, it's going to be weird, right? So let me see, my pen is 2 units long, right? You guys see that? Okay, so let's go 1.5. Cool, so I'm going to hold this one in the middle, so I've got 1.5 for my fingertips at the end. That's 3 units. So these are the units that are, or these are the points that are 3 away. You guys see that's the point I'm looking for? On the y-axis. That's the one I'm looking for right there. Because it's 3 units from 2, 1. And it's 0, comma something. Is there another one? Oh yeah, there totally is. Like right there. You guys see that? So what should I be trying to do? How do I set this up? Won't work. If you add and subtract 3 from this, it'll give you points that are 3 units away, right? But only vertically. They don't look like 0, comma, question mark. They look like 2, comma, question mark. See that? So if I start with this guy and I think, okay, I'm going to do 2, comma, 1 plus 3 and 2, comma, 1 minus 3, right? Okay, this is 2, 4, and this is 2, negative 2. Those are, I agree, 3 units away, but they're here and here.
Well, why wouldn't we be using, we're only doing it for the y that goes, the x is still stay 0. For the second point.
But those aren't these 2 points then. So I'm looking for a point that looks like 0, comma something that's 3 units from here. So I'm looking for, okay, if it's 0, comma something, it's blue,
Right.
and then it's got to be 3 units away. So if I get 3 units, right? So 3 units is maybe this far. There's one. But I don't know how to do that algebraically, right? So what I need to use is my new toy, my distance formula. So what am I saying that's 3 units from? That's saying the distance from this thing to this thing should be 3. You guys see that? So I want us to say, okay, let's apply the distance formula to those two things. This one's sort of annoying, right? Because I don't really like putting question marks in equations, so what do I want to put in there? Yeah. I could put an x in there, that'd be really confusing because it's a y coordinate, right? So I might put y in there. So I want to find the distance, right, from 0y to 2, 1, right, is 3. You guys see that? Okay, so what's distance? That's d is square root of stuff, right? Okay, so what are playing the x values here? 2 and 0. So maybe I think, okay, this is going to be 0.1 and this is going to be 0.2, right? So really I'm thinking x1, y1, x2, y2. Okay, so I get 2 minus 0, and then 1 minus y. Oh, but what should the distance be? Oh, so I didn't really need a variable there, right? I wanted 3. You guys see that? Okay, so, oh, crazy, look at that. So I have 3 is the square root of, what can I simplify? 2 minus 0 squared is 4, and then I've got this other stuff. 1 minus y squared. Cool? All right, so this is the stuff in section 10.4. We want to solve equations used with radically things, right? Okay, so here's an equation in y's, right, with a radically thing. So I should try to solve for the y's. Okay, but this isn't different than anything else we know. We just want to get the y by itself, right? Okay, so how do we get the y by itself? Yeah, there's the square root in the way. Okay, so I want to get the square root out of the way. What do I do to the whole equation? Square it. Really, I'm squaring both sides here. What do I get? 9 equals
4.
Yes. Nice try. Because it's not a difference of squares. It's a perfect square. So now I want to get y by itself, right? So I want to get the stuff that's not y's to the other side.
Wait, where did you get rid of this?
Yeah, I got rid of the square root, right? Where'd it go? Well, when I squared both sides, I kind of undid it, right? Okay, now what? Now I want to subtract 4 from both sides. So I get 5 is all of 1 minus y squared. And then what? Oh, okay. I want the y's by themselves, right? So I should square root both sides. So I get 1 minus y. So here to here is plus minus square root both sides. So I get 1 minus y is plus or minus the square root of 5.
I missed this step. Like, can we do that last?
Yeah, so this step was, I had some stuff with y's and it squared, right? I want the y's by themselves, so I square root both sides. Okay, so I'm here. Now what? Okay, I subtract 1 from both sides. I get minus y is minus 1 plus or minus the square root of 5. Now what?
You can do the -1 as well.
I should get the -1 out of there, right? Because I want y equals, so how do I get the negative off of the y? Multiply both sides by -1. Or divide both sides by -1, or flip the signs and everything. Flip the signs and everything is a bit weird here, right? What do I get? I get y is 1 plus or minus the square root of 5. Why didn't the plus or minus switch?
Because it's a plus and a minus.
It's already both, so it may as well stay both. Some books will write minus plus, which means the same thing, right? So, oh look, that's cool. That actually got me the 2 points I was kind of looking for, right? Okay, see that? So my answers are 2 points. They're 0, comma, what? 1 plus square root of 5, and 0, comma, 1 minus the square root of 5.
Are we going to be?
Apparently not, because we're out of time.